All right, looking at worksheet 4, number 18. Our first clue that something is not quite right is that the arguments are different. So, Abby, I can't do anything until I get those arguments the same. But I do know a formula that I can replace sine of 2x with. So that would be 2 sine x cosine x. And then the rest of the problem stays the same. So sine x equals cosine x. So, kind of tight for space. Can do a couple things at once. So sine times sine is sine squared. And I'll move the cosine over. And okay, so now I've got everything in terms of x instead of 2x, so that's good. I see that both of these have a cosine in them, so I can factor out that cosine. And that leaves 2 sine squared x minus 1 equals 0. Set each factor equal to 0. So cosine of x equals 0. And how much do I want to do at once here? Sine squared x equals 1/2. So set it equal to 0, add the 1 over, divide by 2, 3 steps at once. Hopefully not too bad. So this one I'm ready to answer. Cosine is 0 at the top and bottom. So pi over 2 and 3 pi over 2. The other one needs a little bit of work. You need to square root both sides. So sine of x equals plus or minus 1 over the square root of 2, which is the square root of 2 over 2, which is rather convenient because that's a unit circle value. So sine is root 2 over 2. With the plus or minus on there, I'm not really worried about quadrants because it's just going to be all of them, but all the pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So, number 18. A lot of stuff going on in 18. Started with our knowing a double angle formula, and then we had some factoring, and then some square rooting, and then having to know the unit circle so we could pick off all those values. So that was a good one. A lot of stuff going on there.
Can you work it by dividing out the cosines at the beginning? Or
like at this step?
yeah, after the first step.
So that's a really good question. Yes, can we work it by dividing out the cosines right here, I guess, or right here, either one. So the answer is kind of. If you divide out the cosines, you'll end up with these answers, but you would miss these answers. If you divide by a variable, you lose that part of the solution. So the answers you get aren't wrong, they're just incomplete. Does that make sense? On a much easier scale, if you have, because this is a big deal, it happens a lot. If you have x squared equals 9x, if you divide by x, then you get x equals 9. And that's not wrong, but if you move the 9x over like you're supposed to, and then factor out the x, you get x equals 9, but you also get x equals 0. So if you divide by a variable, you lose that solution. So the solutions you get are accurate, they're just not complete. So again, that happens a lot because it's really tempting right here to be like, I can divide by cosine and simplify my problem. Well, yes, but oversimplify and lose answers. Other questions from worksheet 4? Number 12. Okay, so kind of in the same section, part of the same issue here with that sine 2x or sine of 2t sitting there. So in place of that, we'll put 2 sine t cosine t. really similar now because I can factor out the cosine of t. And that leaves 2 sine t plus square root of 3. Set each of the factors equal to 0. So cosine of t equals 0. And just in the interest of saving space, sine of t would be negative root 3 over 2. And that's a unit circle value, so you feel pretty good you're doing it right when that shows up or when that happens. So cosine equals 0. We just did that problem. That was at the top and the bottom. So pi over 2 and 3 pi over 2. And sine equals negative square root 3 over 2. So that would be steep angle in the bottom quadrants. Sine's negative in the bottom. So that would be over 3. And so over 3 would be 4 pi over 3 and 5 pi over 3. Good questions, because these equations combine lots of stuff that we've already done, plus the new stuff that we're still assimilating, I guess. Anything else? We have time today. Like, notes are fairly short, assignment's not long. Good day. 22. Okay, so this is one of those proofs. I know we don't like the P word, but it tells us work on the left side to make it look like the right side. So let's see. Sine of 2 theta. Well, I know the 2 theta stuff's got to go, so I can replace sine 2 theta with 2 sine theta cosine theta. And cosine 2 theta, that's one where I've got options. It equals cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. So I got to pick out which one of those is the best plan. Let's see. Okay, I'm not allowed to work on the right, but that doesn't mean I'm not allowed to think about the right-hand side. Tangent is sine over cosine, so I'm thinking I would like to be left with sine in the top, and I would love for the cosine to cancel out. So maybe if we use this one, then the 1 minus 1, I think that's going to work. 2 cosine squared theta minus 1. So the minus 1's cancel, or the 1 minus 1 cancels. Cosine over cosine squared, well, the 2's cancel. I guess we can do that. And that leaves us with sine over cosine, which is tangent. But that's a tricky one because you don't know. You got to figure out which one of those 3 to use. And if you use the wrong one, you kind of be spinning your wheels. All right, good questions. Let's talk about half-angle formulas.